Well, hi. Welcome to Infrastructure in the Cloud Era. I'm Adam Jacob.
And I'm Ezra Zygmuntowicz.
And good to see everybody. So we're here to talk a little about bootstrapping. But before we get into that,
we're going to create a little ad hoc cloud here towards the end of the presentation. So if you want to join in, run this command. If you have a Mac.
And trust us. We promise it won't do anything super
terrible. Yeah, we promise
terrible.
we won't root your boxes.
Like, we're really, I mean, we're honest systems administrators. We never do anything terrible much.
And
so,
we'll leave this link up on the slide so you can keep doing it.
Yep, every slide will have it there. So what we're going to talk about. So we're actually going to talk about three things. So one, bootstrapping. Two, configuration. And three, command and control. So bootstrapping is the process of getting a system from procurement, so like, I need a new piece of hardware, all the way through to having it up and running and on a network.
Right, and then so that's the lowest layer, and that would be a layer that would be provided by like Amazon or another infrastructure as a service provider or your hosting provider. Basically, this is rack and stack a box, give it network, give it storage, give it compute, have it up and running with a base OS that doesn't do anything, right?
Yep. And then we're going to talk a little about configuration. So configuration is what happens after that. So you've got your resources, they're up, they're running, you can talk to them on a network. Now they actually need to do something useful. So actually turning them into a system that you can actually run is configuration.
Right, so that's bootstrapping is the bottom layer of the pyramid. Configuration is what happens after you've got a bootstrap system and you want to bring it up into production where it's actually doing something useful.
And then finally, we're going to talk about command and control. So command and control is you've got your system, it's up and running, it's all configuration managed, everything's cool. And now you actually need to do work. Like, you're doing new things. It's not steady state anymore.
Right. You need to run a deploy. You need to check on the status of the system. You need to tell it to rerun its configuration management tool again, or what have you.
And we're not going to go super deep into the tools that we're going to talk about in this presentation. So we're going to talk a little about kind of the theory of how you should be thinking about building a fully automated infrastructure. Later on tonight, there's a Chef BOF at 7:30. Ezra and I will both be there. So if you want to go deep into what Chef is or how it works or how Nanite works, come to that, and we'll both be there, and we'll give you all the technical depth you want. And there's lots of different tools we're going to talk about. So use the one that's right for you.
So
bootstrapping. So this is, like we said, this is the first layer of the pyramid. So getting from procurement all the way through to up and running on a network.
So yeah, so there's a bunch of different approaches to this, right? And as time has progressed, you'll see that the time that it takes to get something bootstrapped has dramatically decreased. And you hear lots of people talk about cloud computing these days and how it's so much cheaper or this or that or the other thing. And in reality, cloud computing resources tend to be more expensive than on-premises resources or dedicated colo boxes or whatever. But the real way they save you money is in the time to market and the time to change the shape of your system, right? And
exactly.
Time is money, and so that's where you save money with cloud computing.
And you know, back in the day, all of us have kind of gone through the old school corporate approvals process, I would imagine, right? So this is where you've got, you know, an IT department. They approve all the different kinds of hardware you might buy. You have to go begging, essentially, for hardware. You can have anything you want, as long as IT says it's okay, right? If IT is like, no, we don't do solid-state disks, then no solid-state disks for you, right? But you know, you do have some known quantities there. So that's kind of good about that corporate approvals process. One of the things that's bad about it, though, is it's really wasteful. So people tend to hoard in that corporate approvals process, right? Because they know it's hard to get gear. So they'll be like, man, this service really needs like 20 systems, even though you need 5, just because you know that there'll be something else you're going to need them for later. So that hoarding is really wasteful.
Yeah, it also gives you a real blocky way to scale, right? You got to wait 2 months to get new servers, so you're going to try to over-allocate. So there's going to be a lot of waste in there. And with this type of bootstrapping, there's no, you know, I suppose you could write an auto-scaling tool that puts in purchase orders for you and hounds the humans and you know, it's like auto-scale, and like 2 months later, you got a new server
is actually
online.
like sending a PO and then some guy auto-signs it. So yeah, it usually takes 6 to 8 weeks in that old school way, right? You need to actually go through the PO process. You need to send it off to your vendor. Your vendor has to build the system. They have to ship it to you. So usually 6 to 8 weeks from placing an order to a human being putting it on a network.
And then you've got your agile corporate approval, which people, you know, you streamline this process. You've got it down to 2 to 4 weeks. Maybe you have a budget that's pre-approved by your IT manager. You've got a known set of hardware that you can buy or whatever, and so it's just a little bit quicker to get it through the system. But it still takes time to ship, rack and stack, all this kind of stuff, and get it through there. And so you're still wasteful. You got a little bit lower time, but you still have to be, with 2 to 4 weeks lead time, you still have to be a real expert capacity planner to be able to manage your peak volume without being way over provisioned all the time.
Exactly. And then you've got the cloud, right? So, and by cloud, what we really mean is something that provisions those resources for you. So the resources are out there somewhere. You don't have to necessarily order them, and there's an API you can call. And so what's cool about that, variable costs, right? So you are only paying for what you consume. It's highly adaptable to whatever your needs are at the time, even though it's not necessarily adaptable on a hardware level, right? Minimal lead time, doesn't take very long. Just fire off the API and the systems show up, right? And you don't necessarily need any human beings involved.
Right, and there's lots of trade-offs at all these different levels. You know, you probably have more control over the exact hardware you get when you're part of the provisioning process and you're you're ordering yourselves, and you can hand choose every little detail of the system. So you can get you could probably get a more optimized high-performance boxes out of that way, but it's going to take you a lot longer to get them provisioned. Yep. Whereas at the opposite end of the spectrum with a cloud provider, you kind of just take whatever you can get, and you need to maybe re-architect your app to be able to take advantage of many more parallel, lower performance machines. But you get the flexibility of not having to over-provision, being able to scale up and down on demand and all this kind of stuff. So
but there's trade-offs. In the end, that's exactly what you're trading off. It's your app has to be built to fit the cloud provider rather than you being able to choose hardware that makes your app work better.
Right. Most cloud providers, the best way to scale out on them is more of a horizontal scale out, rather than if you're provisioning your own hardware and you've got some huge Oracle database, or you've got something that you don't want to re-architect, you can scale it vertically quite a bit further with your own hardware than you can on the cloud.
Exactly. So the important thing to take home here is that the thing that's cool about the cloud is not that it saves you money or magic unicorns. It's that it takes less time. So when you're evaluating these bootstrapping options, that's the thing that actually matters, and that's the real thing you care about. So it's not that it's EC2 or that it costs less money. It's that old school, 8 weeks. Really great at the old school method, 2 weeks. Using something that has an API,
10 minutes.
Boom.
Yep. So that's really where, if you do an effective cost analysis of a cloud versus your traditional infrastructure model, you're not going to save money on the cost you're paying for the hardware. You're going to save money on the time you save and the malleability of the resources enabling you to scale up and down based on load.
So there's a whole bunch of tools that can help you with bootstrapping, right? So for the do-it-yourselfers, you kind of can break it into 2 layers. So one is the actual like imaging and provisioning layer. So these are tools like Pixie booting, it's FAI, it's System Imager, it's Kickstart and Cobbler. You've got businesses like Cohesive FT and RPath, where their entire existence in life is to help you pre-configure images to run, right? And
then you've got this, all these cloud providers that are popping out. You know, Amazon is the prototypical example, and everybody's copying them. The new Rackspace Cloud, GoGrid, you got Eucalyptus to build your own private cloud, and there seems to be a lot of movement in that kind of space. I'd expect to see more turnkey, make your own private cloud solutions popping up here in the future.
Yeah, both Eucalyptus and OpenQRM, right, can give you that same kind of API call to provisioning. So you may still wind up buying traditional hardware and also get that benefit of 5 to 10 minute provisioning times, which is awesome. Right. So you can still have the best of both worlds, even if you don't want to trust a cloud provider necessarily with the people who are provisioning the resources.
Right, and then you've got the layer that sits on top of all these, RightScale, Scalar, what we do at EngineYard, which takes the building blocks of the basic Bootstrap cloud resources and assembles them into a best practice deployment for you and manage those resources for you. Because most of these clouds, like Amazon, it's still pretty low level, like that, you know, give me a block device, give me some compute, I need an IP, I need this or that, and then they're like, here you go, just a big bag of blocks, and it's up to you to take those and build your castle how you want it, and that's the most complex part of those systems, I think. So we're going to show a little demo of what you can do with all these kind of tools to rapidly bootstrap new deployments. I am going to demo EngineYard, which is a commercial product, but this is all built on open source tooling, so you could build this kind of stuff yourself.
Yep. We kind of decided that we would rather show you the functioning awesome that's on top of the open source stuff rather than build a less awesome looking open source presentation.
Yeah, so let's say we want to create a whole new environment. We'll call it Velocity Demo. Here, let me just go through this stuff. We'll pick an availability zone on Amazon, pick a web server stack, and create this up. And we'll attach a Rails application to it, give it a domain name. And then we'll go ahead and boot a cluster here. Based on all the information, I'm skipping a few pieces, all the stuff I've already collected about this application and whatnot, but we can decide how many application servers we want, make a separate database tier, and boot all the stuff up pretty simply. And you can see down here at the bottom, we've got a cluster booting. This is going to take a little bit of time to go out and let Amazon provision these servers. But so this makes it so your developers can get their applications online with a fully replicated, clustered, monitored environment like super easily.
Yeah, and if you contrast that to the old method, which would be, hey, we need a new QA environment for this app. Let's go ahead and requisition new gear. Or if you have the gear handy, then let's go ahead and turn around. We'll put in a ticket request. The ops guys will install the operating system. A couple days later, your system shows up. Like, building systems like this, being able to call an API, that's the sauce.
So we're not going to sit here and wait for this to go. We'll come back and check on it in a minute. Meanwhile, we're going to talk a little bit about the configuration layer, which is what this is going to be doing here in the background in a minute, which is Amazon is acting as the infrastructure provider for me. They're doing the bootstrap as far as I just make an API call to them, and they return me back some servers and some block devices and some IPs and stuff. And then I'm going to take those raw resources and configure them to run this application. And what that means is I get basically the way I like to work on Amazon, lots of people will make an AMI, which is a machine image that's bundled up, and then they will edit that and get it all configured right, and they'll freeze up another image, and they'll deploy from those images. And I believe that that's the wrong way to go about this. I think that you should have a golden master image, which is basically an embryonic image that can become anything when it grows up, but it's very slimmed down and just has some base packages installed, but nothing configured to run. And then when that image wakes up on Amazon, it can call back into my app or whatever central server you set up and say, hey, I'm here, I'm ready, what am I supposed to be when I grow up? And the central server can say, hey, here's some information about what you're supposed to be, here's some config management recipes to run, here's all the attributes you need to know about your other servers in your cluster, and then the configuration management tool can take that information and configure every aspect of the system. Configure MySQL, configure replication, install Ruby, get it configured, configure your app, deploy your app from a Git repo, configure monitoring, all the different aspects of a production system that, a lot of the time in the old days you do this by hand. You get a server, they'd hand it to you, and then you'd go hacking away, typing away, and you'd finally have it set up a week later. And then what happens when that disk drive blows out and you don't have a backup that's more recent than a few days? There's all this state that lives on there and lives in your head, and servers become these little graveyards of state, and they become very hard to reproduce.
Yep.
So a much better way of doing it is to never let the server care about the state. You treat the servers as disposable, and they're completely rebuildable at any time from all the metadata you've collected about them.
But what that means is you wind up having to actually go through this process of determining all the places, all the components, all the things that need to happen throughout your whole infrastructure, and manage all of that complexity. You have to pull all of that stuff together in a way that actually lets you write it out somehow as code and manage it. So some of the options you have for managing that complexity, there's the old school manual way, right? Sysadmins writing commands into terminals. So what's good about that? Because there are some good things about it. One, you can do anything you want because you're a human being. So when you get into that moment and you're like, wow, this is a complicated thing, you as a human being are uniquely talented to cope with that problem. And no script is ever going to replace your ability to innovate in that moment, right? It also kind of gives you that intimate knowledge of the details, right? Like when you've sat down and done something by hand and like just super homely crafted that server, man, you know what's up. And if you use automation that you didn't write or that you didn't go through that process, you don't get that knowledge. So,
you might not have as clean a picture in your head of what actually happened to make a system go.
So what's not so cool about that approach, though? It's slow. We're meat. It's slow. And it just doesn't work quite as well. It's also error-prone, right? So if you get hit by a bus, well, there's nobody left to make those innovative decisions to like help configure your infrastructure. It's not very repeatable. You make mistakes. I'm of the opinion that basically for every 10 commands I have to type, I'm going to screw up one of them, unless I'm cutting and pasting at some level, right? So you're going to make mistakes. And it's difficult to transfer that knowledge, right? It's hard to actually get someone to sit down with you and be like, look, I'm going to now impart all of this wisdom about how I finally crafted this system.
Right, and then their system's completely susceptible to the bus error. What happens when you get hit by a bus? your system's gone because all the knowledge was in here and you don't have any snapshots of your brain.
Yep. So the ad hoc way is what most of us have been doing for our whole systems administrator careers. So this is where you encounter a problem, you do it too often, you're like, man, it's a pain in the ass, I have to go out and like rotate log files, or man, it sucks, I have to go manually configure monitoring. So you write a script, right? And then you use the script to do it for you, and it goes out, and that's better, right? It's more repeatable, the knowledge is more dispersed, you built it your way with your model, right? So it's exactly how you want it to be, but it has some downsides. So one, it's rarely idempotent. And what we mean by that is, if you do it, what happens when it dies in the middle, right? So you write this awesome script, it does something, and then it gets halfway through, and something it didn't expect happened. Usually, you have to go back through and like comment out everything that was up there before it, because it's not written to be that way, right? So that sucks. It's also kind of hard to collaborate. So outside of your org, it's hard to collaborate. Inside your org, you might have somebody else that is checking it out and knows kind of how you've written the code, but I can't really mail you my script for managing my log files, right? And if I do, it's just going to be a place to start, and then you're going to make it your own. So it kind of results in this sort of brittle, hard-to-collaborate thing. And I'll get to this point later, but there's no API to this layer, right? Like you can't come back and drive it again. Like everything is one-offed.
Right, everything is these one-off shell scripts, and you end up with this big repo of like 300 shell scripts that you might reuse and you might not, and nobody else knows what they do. So that's kind of the downside of that. And then we move up into the infrastructure as code, which is what Adam and I really believe in. And this is repeatable, idempotent config management tools like Puppet, Chef, CF Engine, BFCG2, Automated, a bunch of these different tools. And the main takeaway of all these tools is the idempotency. This means they're all kind of declarative. You write your recipes in a declarative format. You say, I declare that there is a directory with these permissions here, and I declare that this package is installed and that these services are running, and that this template config file looks like it should. And then you run the system over and over again, and if your system runs through all your recipes with no errors, your system is going to look like you declared it to look.
Yep.
And the coolest part about that is you can run it over and over again and have it always converge on the right state. So if it does break halfway through, you can see what the error was. Maybe there was a transient error from your upstream package manager host went down, or Ruby Forge went down, and you couldn't install a gem. So you run your recipes again, rather than the old shell script way where you have to figure out where it broke and go comment out a bunch of stuff and hope that it actually runs again. The whole point of these systems is to run these recipes over and over again all the time. In a way, they become like unit tests for the state of your server. When these things run and pass, it's like your specs pass on some code, and the system looks like you wanted it to look like.
And that idea that it's really source code is important, because it kind of that it's reoccurring throughout this whole process of learning to like build more and bigger and larger automation for your infrastructure. Is that when you start to treat the way you build your infrastructure as source code, all the tools in your disposal to manage source code, they come into play as well.
Yeah, so if we look back here, we can see that some of our servers are already finished and are running. We have one server that's lagging that Amazon hasn't even booted yet, so sometimes their boot times can vary. But
which now shows you some of the failure conditions when you expect that you get a 5 to 10 minute variance there. Sometimes it's closer to 10, sometimes it's longer than that.
So that's the beauty of live demos. But yeah, you can see now we have a full Ruby on Rails app running in a cluster with a database and all this kind of stuff, and it was really easy to provision this. And if this thing happened to crash or whatever, we could totally easily replicate it in another few minutes by just booting another one. So I'll leave this going. We'll go back here.
We'll come back to that one more time.
Yeah.
So tools for configuration, we mentioned some, Ezra did just a second ago. So you've got tools like Chef, you've got tools like Puppet, you've got tools like CF Engine, bconfig2, Automate It. All those tools can get you the sort of properties that we listed off as being good about having infrastructure as code. Not all of them are quite as accessible as APIs. But we'll talk about that in a second.
Yeah, we have strong opinions on which ones we like, but like the main point is like use one of these.
Yeah, just use one. You'll be so much better off if you pick one. And anybody who hates on you for it, they're probably wrong if you're building good infrastructure.
Yeah, one more point I wanted to make back on this slide that I forgot is, earlier on we talked about the time to bootstrap. 4 to 8 weeks, 2 to 4 weeks, 5 to 10 minutes. And that really plays in with the strengths of these config management tools. Like if it used to take you 4 to 8 weeks to get a server, and then it took a guy a week to configure, that's not really that big a deal, because 1 week on top of 8 weeks doesn't really matter that much, right? But when you get down to the cloud and you can provision these bootstrappable resources in 2 to 5 minutes, and then your config management tool takes over, If it takes you a week to configure a server, you've totally just ruined the whole advantage you had of using a cloud.
Right. There was no point in having that provisioning API.
Right.
Who cares?
So that's why these tools become more and more important as the resources you manage become quicker to provision and decommission.
Totally.
Your tools need to be quicker at doing that.
And the other thing that we should say before we leave is hard things are still hard. So like there is no magic unicorn, as much as we want there to be one. And so it's hard to build multi-master MySQL replication scenarios that can cross data centers in near real time and not lose data when you have an outage. That is hard.
None of these tools will fix problems of underlying infrastructure for you. They'll just make getting into those situations where it crashes a lot easier.
They may be easier to get out of, but they still suck when they happen.
Yeah.
All right, so other tools you can use, shell scripts, Perl, Python, Ruby, whatever you got. Use that if you have to. Otherwise, it's the OS tools in your text editor, right? It's you and VI against the world. So this is a little bit of infrastructure as code as an example. So this is a little snippet of Chef that configures sudoers. So everybody in this room, I'm sure, knows about sudoers. So the important part here is you're managing configuration as idempotent resources, right? So this little code snippet defines two resources. One is a package, the sudo package, which we say we want to have always upgraded. So we want to make sure that that package is always at the latest version. And then we also render out the sudoers file as a template, right? And there's some variables there that say what the template is coming from and then where it's going to wind up. The important part there is we ship some variables off to it, right? So what you're doing with those variables is actually kind of programming Chef like an API. What you're saying is, whatever is in the value for these groups and these users, that's what's going to wind up in the sudoers file. So whatever your policy is for who gets sudoers rights on your system, Chef doesn't necessarily control that. You do. But you can still get the leverage of having this programmatic infrastructure already exist, because all you need to do is, if you put the right data in that data structure, what's going to pop out the other side is a correctly configured sudoers file.
And it still gives you like the same kind of separation you get in like a model view controller web framework, where you separate your data from your templates, from your views and your controllers and your models.
Yep.
With Chef, especially the way I tend to do it, which I'm making these recipes that have to be general purpose for a whole range of people hosting Ruby applications. And so I make generic recipes that take as input a big JSON file that's like the DNA of an instance. Earlier I talked about having an embryonic kind of stem cell base AMI image. So what I see is you got a base stem cell image, you've got your Chef recipes, which are like the computer that runs the DNA, and then you've got your JSON, which is like the DNA that tells an image what it's supposed to be when it grows up. And you combine all those two together, and it grows organically into exactly what you wanted it to be.
Yep. And the important bit there is that it's actually an API, and you can get to it in a bunch of different ways. I'll talk more about that at the Chef buff. But, and once you've got this stuff as code, you can track it like code. So in case I haven't said it enough times, all of these layers must have APIs or the whole thing falls apart. So
yeah, data centers without an API are obsolete these days.
That's right.
There you go.
Yes. So if you don't have an API to all of these different layers we talk about right now, you are hamstringing yourself. And it won't feel like it when you first start out, because you'll be getting all these great gains, and you'll be like, wow, this is so awesome. I'm declaring my infrastructure, and it's totally working, and I'm doing some stuff. But if you don't have that API, the day will come where you're like, you know what would be great? If my monitoring system could automatically update my config management system and notify the bootstrapping system to deploy a new thing, and all that stuff should work in a circle. And that only happens if you have an API. So no API, you're done.
It's kind of the same thing as like dealing with bottlenecks in a web app. It's kind of like this thing that looks like a stairs. It's like, oh, we hit the wall. Okay, we solved that bottleneck. Boom, we're good. Now we hit the wall again. We got another bottleneck. We solved it and we hit the wall again.
Yep.
Now it's the same thing applied to your infrastructure. When you make bootstrapping on Amazon makes it so fast that it takes a few minutes, now you've hit the wall and you feel the pain when your config management tool can't do it in a few minutes too. So then you fix that. You hit these other walls, so it's this constant banging your head on the stairs as you go up the stairs. And that API need, that
is the wall that comes to you right after you get config management working.
Yeah.
So, command and control.
So command and control is the kind of third layer that happens, okay, I bootstrapped a system, okay, I took Chef and I configured that system and I've got an application running. It's in production, it's monitored. Now, there's ad hoc things you're going to want to do to this. You're going to want to deploy source code, or you're going to want to trigger your config management tool to run a certain resource, or you're going to want to trigger to set a different threshold for your monitoring, or any kinds of things that are kind of one-off that you probably used to do with SSH or Capistrano or something like that.
Yep.
You need this it's kind of like the third layer on top of bootstrapping and configuration management is this command and control of a bunch of systems tier.
Yep. So, like always, we're back to the good and bad slide. So the old school way of doing this is the meat cloud. So Andrew Schaefer coined the term meat cloud. Andrew has a talk that's happening here a little later, Agile Infrastructure. You should totally go check out his talk, because Andrew rocks. So the meat cloud is all of you. Everybody who does operations, we're the meat cloud. And so what was good about us doing those command and control steps, we were really flexible. Something happened, we do it, we're humans. We can do anything we want because we're human beings.
We can make pretty intelligent decisions.
Usually. It's also easy to find someone to blame, right? Like when you know that there's some guys who are going to go do that work for you and they screw it up, you can be like, Bob, what is up for missing that command? And they have free will, so they can innovate. That's also kind of a downside, though. People have free will, so they can innovate, which means they don't always do it right. It's error-prone, it's slow. It costs a lot to scale the meat cloud. Like, we got to have health insurance. There's all sorts of stuff you got to have for people. So people can do this.
Takes a long time to provision meat cloud.
Yeah, it does take it takes a long time to provision a new meat cloud resource. So then you have like kind of the ad hoc way, right? So the ad hoc version of command and control is just like the ad hoc version of config management, right?
It's like SSH in a for loop,
yep.
right?
It's more repeatable. It's easier to scale. It's less error-prone, hopefully. It also is rarely idempotent, just like the config management stuff was. It is still better, though. So the first time you put SSH in a for loop, you were the total king of the universe, right? Like, that was the coolest thing you'd ever done.
Yep.
And so it's awesome that you can do that, and it has value. But the places where you run into a wall, it's one-off by necessity, just like the other stuff was, right? I need to do this on 10,000 servers. Well, OK, I'm going to write that script. You get this tool sprawl. So this is that subdirectory that you have for your infrastructure that's full of little shell scripts that, when this happens, you tell the NOC guy to go run that script and everything's going to be better. That's what tool sprawl is, right? So you wind up with like 100 files in a directory and that runs your infrastructure, tooling sprawl. It's hard to share, right? Unless you have the same infrastructure I do, those scripts probably don't go back and forth. And the learning curve is way higher than the meat cloud, right? You can send somebody to like a conference, or they can give them training and they can go learn about Red Hat or whatever, but they can't learn about your custom shell scripts.
Right. And so then you have the higher level framework, which would be like Capistrano or Nanite, which we're going to show, or some of the other tools, control tier or whatever. And this is more of an organized framework for managing this command and control tier. Most of these end up using some kind of message bus. Nanite uses RabbitMQ as a message bus for this. And it's the same kind of constraints as a framework gives you, like something like Rails. It gives you these constraints. If you paint within the lines, you get all this stuff for free, and it makes things really easy to work with. The downsides of that is if you don't fit within the lines, and you're kind of shit out of luck there.
Yeah, time to repaint your infrastructure inside the lines.
Yeah, so this is also usually more repeatable. It ties in with your config management system to trigger resources, and it's two-way communication. SSH is mostly one way. You're here, you tell it to run over there. It doesn't really talk back to you that often.
Yep, and again, you wind up trading depth of knowledge when you use these tools, right? So if you pick up something off the internet and you're like, sweet, this will plug directly into my command and control tool, you don't understand what it does, you have lost that chance for knowledge, and in a disaster, you won't know and it will be trouble. So different tools for command and control. We talked about Nanite. And we're going to show you Nanite here in a second. Capistrano is a really common one in the Rails community, parallel SSH plus little Ruby workflows. Control tier is a very cool product that usually the Java guys wind up using that can do this sort of kind of complicated command and control. Shell scripts in the meat cloud.
Yep. So let's do a little demo here. Let's see if anybody actually joined our cloud or not.
Oh, yeah.
You guys did. All right, cool.
So now what you need to do is turn up the volume.
Yeah, let's have you guys turn up the volume.
So yeah, you all turned it off because you're good citizens in talks, but now you're free from that requirement. So what's really interesting about what just happened there is that while that thing just says whatever Ezra tells it to say, which is kind of cool, you could be doing almost anything with that, right?
Yeah, so the way the system works, this is just a simple little admin, but you can see down here, we've got the running nanites, which is everybody who joined as an agent, and everybody who joined in has given me an identity where I can address them with. They've given me their load average, so I can make decisions based on their load. They've given me a list of services that their agent provides, and then they also have tags. Your guys are all tagged with velocity. So with this system, I can send commands to all of you, I could send commands to a specific person, could send a command to a random one, or to the person with the least load average. So it's helpful for all that kind of dispatch. We could do cool stuff like, let's see who's got Rails installed. We can see what versions of Rails you guys got. So we can query the cloud and see who's got what capabilities. And we could, I'm not going to trigger anything, but we could trigger your system to run a tool.
If you were all running Chef, you could imagine those resources I showed you earlier that had actions attached to them. You could send those actions down the wire with Nanite, right? You could say, hey, everybody needs to have sudo words installed right now. So,
right, or you could say, hey, query the system, say, hey, who's running Apache 2.2.1? And they all come back and say, I am, I'm not, I am, I'm not. And then you say, okay, all of you who were, go upgrade to, because there's a security vulnerability, that kind of stuff. So it gives you a way to map a query across your infrastructure, get those results back, and then go perform actions on any specific node or all nodes or whatever you want, or what have you.
So that is command and control.
Yeah, let's just say thanks.
All right, so we already kind of talked about what else you can do, but you can think, your imagination can kind of go nuts once you get to the idea that you have this two-way communication channel that works really simply like that, right? Server maintenance, starting and stopping a service, enabling and disabling parts of your application becomes really cool, right? So you don't have to necessarily redeploy to do that. You could just send some signals to your apps. So there's all kinds of stuff that is inside there.
Right, and since we're using a nice messaging bus, RabbitMQ, it works cross data centers, across the country, across the world. You can federate everything up into one kind of command and control cloud, so it's really nice. It also pierces firewalls and stuff, so you could run an agent behind a firewall on any computer, and it's a persistent connection, so it traverses NAT and everything.
It's very cool.
Yeah.
So we're going to talk a little bit about putting this kind of system into practice. So the first one is the most common case that's good for the cloud, and that is typical peak load, right? So this is, I stole these slides from Theo, so wherever you are, Theo, thank you so much for that blog post, because it was great. So the first thing you wind up doing here, this is when you've got, your website goes up during the day, it goes down at night, right? So in this model, it's really easy in the cloudy world, because you bring on capacity as it ramps up, you take it down as it ramps down, it's 10 to 15 minutes on the other side, you can fully automate it because it's predictable, right?
And this is where, this kind of load is where the cloud saves you the most money, because in your traditional infrastructure, you have to provision for those peaks. And so during the valleys, you've got all this excess capacity just sitting there doing nothing.
And the important part here is that it's predictable. So it works when it's predictable. So when it's not predictable, though, you're pretty much screwed. So there's no real way around the fact that you need to do capacity planning for the atypical load. Because these load spikes, they happen too fast, right? It takes 5 to 10 minutes to provision. Well,
it's still too slow.
Oprah's comment went out 5 minutes ago, and in 5 minutes we'll have enough load, right? Like it's better, than having to go out and buy a server.
Right.
Travis Cole from iLike is here somewhere, and he can tell you a great story about how, they actually had to go and literally beg. They were like, please do people have servers, because we need more, because people love using iLike on Facebook. That problem wouldn't have happened in the EC2 world. They might have had other problems, but they wouldn't have had that one. So the important thing here is atypical load, the cloud, not a magical unicorn. Better, but still bad. So this is the slide I'm most proud of. So Amazon recently had lightning strike one of their data centers, right? So this is my awesome, check it out.
There's a good slide, yeah.
So that's bad, right? So doom has struck, and your cloudy cloud, we lost 2 web servers and we lost a couple of database servers, right? And so how would we react if we had one of these command and control systems set up? So basically something like this workflow is what's going to happen, right? So your monitoring system is going to notice, holy crap, lightning struck, right? It's going to send a signal to command and control, which is going to send off 2 signals, right? One is to the config system that says, hey, you better know that these systems are no longer in production, right?
Remove so somebody tries from your load balancers.
Right, if somebody tries to deploy, make that not happen. And then also sends a signal to the bootstrapping system. Need more resources to replace the ones that died, right? So then that goes out, provisions your systems. Theoretically, those then come up through configuration, and eventually they go back into the monitoring system as functional resources.
Right, so let's take a look here. We've got this top cluster running, and the way this clusters work up here on EC2 for me is you've got a fleet of application servers, and one of them is the master, which means it's got an elastic IP address, and it balances, each of the application servers runs HA proxy on port 80, and then their web server on 81. So any one of them could become the master and start balancing to the other nodes at any minute. But the master has the IP address, so it's the one that's actually addressable. So let's pretend our master gets hit by lightning, which is fun.
We should have written like a lightning shell script.
Yeah, I'm just going to pretend by just stopping HA proxy, because that's what it's monitoring anyway for now. But you get the picture. And if we give this like 15 or 20 seconds to react, you'll see that our system's going to notice that the application master was down. It's going to use a technique called stoneth, which is technical jargon for shoot the other node in the head, and it's going to kill that server. The application slave is going to steal the IP address, kill that master server, and reboot a new one in its place. So now you can see the IP was just stolen. And if we reload the page, you see that that old master got killed, and now we've got a new master that's going to come up and join the cluster automatically.
Yep.
And it stole the old volumes from the old master, and it's putting those and mounting on itself. It will come up. Once it comes up and it has an addressable IP, it will tell the system about that, and all the nodes will reconfigure themselves to change their load balancers to point at the new system, and we just self-healed cluster when lightning strike.
And all the underlying guts of that are open source tools, right? Nanite's
Right.
open source, Chef is open source, the EC2 API has write scales, cool gems.
So the only way we can actually make this happen unattended is because everything has an API. So I'm able to write code to do all of this. If there was parts that didn't have an API, it would be like my code would stop and like file a support ticket and wait for some humans to do something, right? Which is not going to do us any good. So the importance of an API can't be stressed enough. It really enables a whole new class of system administration stuff.
And that, I think, is it. Oh, we get to see Doom again.
Oh.
Yay.
Yay.
All right. Doom. OK.
Is that it?
Yep. Oh, so this is a couple of wrap-up slides. So the basic gist from us, if you haven't got it already, is this is the way you're going to automate your infrastructure.
Right. You've got your configuration management tool running on a loop every few minutes or half hour or whatever. You've got command and control running certain queries
doing ad hoc
every
stuff.
few minutes, checking the health of everything and noticing when something happens, analyzing what happened and trying to fix itself out of that situation by booting more nodes, killing other nodes, all this kind of stuff.
Yep. A couple of things you should be aware of. This means your infrastructure is essentially disposable. That's good. Make sure you can turn each layer off. This is a very common theme here at Velocity. Twitter can do this. Flickr can do this. Your infrastructure should be able to do it too. So
you need knobs.
Yeah, you got to be able to be like, you know what, command and control system or config management system, you are going to screw me up right now. Please just stop.
Go away. I need to do this by hand right now.
Sometimes the meat cloud's best. And then finally, when you start going down this road, you're going to meet new problems. So now you're more efficient. So you've unmasked a whole new class of problems you didn't even know existed beforehand. All right, so I think we have 16 seconds for questions.
In your example of the scope situation, you actually having the healthy node use Amazon's API to kill the other one?
Yes. Yeah, it uses Amazon's API to violently terminate that other one. It's reliable. You can reliably terminate a node unless they're having, I shouldn't say reliable for much to do with Amazon. 98% reliable with weird outliers is how it works up there. So most of the time, yes, you can totally kill another node via the API. And I experimented with okay, maybe that node's not totally down, maybe it just needs to be fixed, so I'll steal the IP and then try to fix that node. And the networking that happens when you steal an IP, it can take 20, 30 seconds to remap that IP, and meanwhile, the old node doesn't have a DNS name for a little while, and the networking is all wonky, and it's non-recoverable without too much backflipping. So it just becomes much easier, especially since we are treating these resources as disposable, and we have a config tool that can totally rebuild from scratch. Just kill that thing that's misbehaving, put a new one in its place, and be done with it. Turns out to be a much better way of doing it than trying to recover from an error. Yeah, I just wrote some custom daemons that are doing the monitoring, and all the app slaves are doing the monitoring, and when they hit their trigger that says, okay, he's missed enough checks that I want to do it, they all race to grab a lock, and whoever gets the lock wins and steals the IP and reconfigures everybody.
Any other questions? Sweet.
All right, thanks. Come to the BOF tonight if you want any more tech details on all this stuff.